Okay, now we're going to go ahead and look some more at reflections. And when the pre-image is reflected across the line is halfway between the original and the reflected point, so the image and the pre-image. One thing I wanted to make sure you knew is how to write this notation. So there are a couple of different ways to write reflection. For the first image, which we have here, we're reflecting across the y-axis. So you can say R, the little r's for reflection. We're saving the capital R. You can probably guess for rotation. And so then we say, what are we reflecting about? You can say the y-axis, which this is, or that is also known as the x equals 0 line. So that would be good notation for the very first reflection we looked at. For the second reflection, which was across the x-axis, we could write that as little r subscript x-axis or little r y equals 0, because that is the y equals 0 line. Now in your first example, we're going to draw the image for the transformation, but I'm actually going to use some cool software from GeoGebra, which you can download and access for free. And I'm going to click on this little reflection tool, reflect about a line, and I click on my object, I click on my line, and voila, there's your answer. So you can see that C to C prime, it reflects, C prime actually ends up on the y-axis, D prime ends up over here, so it's equidistant from this line of reflection. And there's B prime and A prime. A prime actually lands right on top of itself. So go ahead and copy that drawing down. And again, you might really want to explore GeoGebra. It's www.gebra.org. And it's a software that you can download for free and play with. It's really pretty cool. I can even take these points here. I should be able to take these points here. And actually, I can move them if I click on the arrow tool there. And you can see the reflection moving around. So let's go ahead and look at the polygon in your example. We're going to reflect this one now across the y equals x line. So this is a little bit more complicated than what we were looking at before. I see C, by the way, there's some typos in your notes, so some of these points might be a little bit off, so double check. C is supposed to be at -5, 5. And when it's reflected across this, you can see it goes across the line. It ends up at 5, -5. The midpoint is at 0, 0. D, when I reflect it across the line, it goes all the way to 15, -5. And the center point, the midpoint between those two, is 5, 5. E ends up at 15, 5. And there's the midpoint, 10, 10. G goes from -5 to -5, -5. And guess what? The midpoint is -5, -5. Finally, H goes from -15, 5 to, that should be -5 right there. Sorry about that. And it goes to -5, -15. And the midpoint is at -10, -10. So right here, let me go ahead and put a little negative sign in here. There should be a negative there. Okay. So what does that mean? Well, some of the interesting things you can notice, looking at going from the left to the right, you should see that the only thing that's happening is that the x and the y are switching. So we're going to add that to our notes as a rule for reflection across the y equals x line. And you can tell it's the y equals x line because the midpoints are all the x's and the y's match. 0, 0, 5, 5, 10, 10, -5, -5, -10, -10. So this reflection can be written in the form r with a lowercase y equals x. So compare the slope of the line of reflection to that of the segments connecting the pre-image to the image. Well, you can see the slope of the line of the reflection is 1. It goes up 5 over 5, which is 1. Or you could say up 10 over 10, still 1. Then if I connected these two right here, that slope would be down 10 over 10, so it'd be -1, which means they're perpendicular. So the line of reflection is always the perpendicular bisector of the segment for two reasons. It's perpendicular because it has negative reciprocal slope, and it's going through the midpoints of those segments. And then here's the bit I want you to add to your notes. reflection about the y equal x line looks like this. Basically, x comma y goes to y comma x. Why will this come in handy? Not so much on your geometry test, but you're going to see this again in Algebra 2.